Hello student, this is the third lecture of complex number. In first two lecture, we have studied about the terminology of complex number, the basic properties of complex number, the modulus, conjugate, rotation, Euler formula, and use of Euler formula and all. But now in the third lecture, I'm going to show you how to apply the concepts of these modulus, conjugate, argument, and all in complex number problem. So when we are able to just apply the concept or the properties on the question, then only we'll get marks in our competitive examination or your board examination. So be careful, say this carefully, and apply the same concept in your questions, right? So enjoy this topic and enjoy this whole class, right? Thank you, everyone. We are starting the question of complex number. The first question, the basic one, Z is a complex number. If Z bar is equal to 0, then which of the option will be correct? We know that the formula for Z bar is mod Z square. And if Z is x plus iy, so this mod Z square will be x square plus y square, where x and y are real and this is given as 0. Since x and y both are real, so square of x square plus y square is equal to 0. This is possible for real number of x and y is possible only if x is equal to 0 and y is equal to 0. Means a real part of complex number z and imaginary part of complex number z will be equals to 0. Right? Next one. The multiplicative inverse of z. What is the meaning of multiplicative inverse? We know that the basic of this again, basic terminology, multiplicative inverse of any number is the reciprocal of this. So multiplicative inverse of z is nothing but 1 by z, right? This is multiplicative inverse. But we know that this 1 by z, we are multiplying with z bar in numerator and denominator both. And again, we know that the basic formula for this is z bar, and z bar is nothing but mod z square, right? So z bar upon mod z square is your answer. So we are starting with the basic question, right? Basic question where we have to solve the complex number. So in this question, right, we have to write down this in the form of a plus ib. Everything is given in denominator. We have to write down this in the numerator, and we have to use the basic trigonometrical formula, 1 plus cos 2 theta and sin 2 theta. See, 1 upon 1 plus cos 2 theta is nothing but 2 cos square theta plus I sin 2 theta is 2 sin theta into cos theta, right? So 1 upon 2 cos theta. 2 cos theta, we can write this is cos theta plus I sin theta. So multiply this, right? Now this is coming as a very good condition on this, like we know that this is e to the power I theta or e to the power minus I theta. But the best thing is if I'll multiply this by cos theta minus I sin theta in the numerator and denominator, we know that this will be cos theta 1 by 2 square itself 1 minus I tan theta, right, upon a plus b into a minus b, or z bar. We know that mod z square. This will be mod z square means cos square theta plus sin square theta, and basic formula you know this, sin square theta plus cos square theta is nothing but 1 only. So just simple answer you are getting from this, right? So when we have to write down any denominator in the form of a plus ib, conjugate will give you the best way to get this, right? Alpha and beta are real, right? Then we have to find value of alpha plus I beta is in the mod upon beta plus I, right? See what this, we know that Z1 by Z2 whole is in the mod. We can write this as mod Z1 by mod Z2. Mod Z1 means alpha plus I beta mod upon beta plus I alpha mod. This will be alpha square plus beta square is in the under root. This will be under root of beta square plus alpha square, and right, one of the simplest question I can say, and we are getting the value of this will be 1, right? Again, one of the simple question again is coming, right? Z is a non-zero complex number, right? Z bar upon mod Z square. We know that already solved this, right? Z bar upon Z, Z bar. Z bar will be cancelled out. We are getting 1 by Z. The basic question, but now x plus iy is equals to under root of a plus ib upon c minus id, and we have to find x square plus y square. We can solve this type of question by two ways. Either we can apply the modulus or the conjugate, right? If I'm applying modulus, right? So x plus iy is in the mod is equal to under root of a plus ib upon c plus id whole is in the mod, right? So this is x square plus y square is in the under root, right? And again, we can apply this under root of mod of a plus ib upon mod of c plus id, right? So this will be x square plus y square, squaring both sides. We are getting x square plus y square is equals to a square plus b square upon c square plus d square, right? But one under root would be there, right? So square of this will be, obviously we'll get rid of this under root, and we're getting this a square plus b square upon c square plus d square, right? So here we are applying the formula mod z of under root is same as under root of mod z. So the key point for this question we can say would be this one. Again, if you'll see this question carefully, again you are getting the same thing in different question. See, this is 1 plus I, 1 plus 2i, and so on, and we have to find value of 2, 5, 10, and 1 plus n square. We know that if I'm taking modulus of every number, what is given there, right? So this number is coming as root 2, this number is coming as root 5, this number is coming as root 10, and this number is coming as 1 plus n square. Similarly, x minus iy, this will be x square plus y square is in under root. Squaring both sides, directly you are getting your answer, right? So only you have to see what we have to apply. Also, what we can do, right? We can multiply with the conjugate of this, means 1 plus 2i, 1 plus 3i, and so on, 1 plus ni. Similarly, this will be x plus iy. Both sides I'm multiplying this, the conjugate of this, then again we'll get the same result in this question. Okay, now, right? Next one. This is very important question, right? Directly we'll get the question of 8 minus 6i is in the under root. We have to find. Like I'll recommend key if you remember the formula of this a minus ib is in the under root is plus minus, right, under root of a square plus b square is in the under root plus a by 2 minus I times under root of a square plus b square is in the under root minus a by 2, right? This whole is in the bracket where a is 8 and b is 6. So if you look into that, right, what we are getting 8 square 64 plus 36 10, right, plus 8 18 by 2 will be 9, under root will be 3 minus this subtracting I. So we are getting two answer. First is 3 minus I and second will be minus 3 plus I. See, if there is a minus sign, then this formula we have to use with minus sign. But if this will contain the plus sign, so here we will change only the plus sign, right? Answer will be in the same form, right? You have to use this a square plus b square plus a by 2 plus, if there is a plus sign, we can use the plus sign for that, right? If more complicated forms are given, right, and then we have to find value of this, right? So how to get the value of this, right? I'll suggest if x or n or something is given now, so it's best way to go for the answer would be put x is equal to 0, right? X is equal to 0, what I'm getting under root of, right, this will be I, the value of under root of I, right? Now, if I'll put 0, this is not coming any terms of, right, 0, 0. So this is minus I, this is coming as I plus minus I under root of not minus I. This is coming as 1. So this is not the answer. This is not your answer, right? At 0, this may be 1 by root 2 plus, there is a plus sign, plus 1 by root 2. There is a plus sign plus I 1 by root 2. So see, both case we are getting the same answer if I'm putting except. So maybe this would be the answer, maybe this would be the answer, but we are not sure. So for x is equal to, we have eliminated this and we are getting two options are there, either 3 or 4, right? Now put x is equal to 1 only. So this is under root of 3 by 2 plus I under root of 1 by 2 with under root, right? And there will get, right, 1 by root 2 plus I times of this with plus minus sign, right? Maybe this plus sign or minus sign, we have to get this, right? So now 1, this will be 1 plus I, right, under root of 3 is in the under root. Again, you have to apply the formula, right? A plus IB, and this you are getting plus minus under root of 3 by 2 under root of 1 by 2, right? So definitely we are getting with this formula, I is there. So our answer will be third one only, right? So carefully only you have to eliminate this, or else we can solve by the basic method of A and B, but that will be very complicated. So go with the elimination. Okay. Now, the principal value of argument of this is given, right? Root 2 plus I root 2. See, This is in the first quadrant, and this is root 2 comma root 2, right? First quadrant, both x and y are same. So this angle theta, so tan theta is equals to 1. So theta mod of this, we know that. So this is pi by 4. Since this is in the first quadrant only, so we know that the answer will be pi by 4. Quadrant is very important. We know that magnitude wise this is 1 only, but in quadrant also this is in the first quadrant, so directly you are getting the answer. But in the second question, this is x is negative and y is positive. There's the point, right? Minus 1 comma root 3, right? Minus 1 comma root 3 is the point, and then we have to decide. So first we have to take this theta is equals to tan inverse mod of y by x. So this is only tan theta getting root 3, right? So we know that this will be, right? So this is x and this is y. So see, this will be wrong. We have to get theta is equal to tan inverse y means minus 1 by root 3. The coefficient of x, the order is not important. The coefficient of the real number is where I is not there. So this is root 3, and coefficient of I is called the y. So minus this with root, right? Minus 1 by root 3 with modulus. So what we are getting? Pi by 6 with magnitude, right? And we know that this is in the which quadrant this is, right? It's x is minus 1, y is root 3 is not possible, right? What is this? This is x is negative, right? And y. So x is root 3 and y is minus 1, right? So it's coming in the fourth quadrant. If the number is coming in the fourth quadrant, then the value theta is equal to minus of pi by 6, right? Minus of pi by 6. So we have to be careful. The first number and second number, we have to first write down this as a plus ib form, right? A is root 3 and b is minus 1. So this is coming on the fourth quadrant, A and B itself, right? Now, if A is the real number, right, is less than 0, then argument of IA, right, we have to find argument of IA. So A is negative, right? If A is negative means if I'm taking some like x plus iy, right? And x plus iy in this form, argument of ia, right? A is less than 0 means this is the real number, and real number multiply with I. So in this case, I can say this will be A is less than 0. So this will be 0 plus I, right? This is 0 plus I way. So theta is equal to tan inverse y by x, right? So this will be tan inverse minus a by 0, right? So we know that this theta is going for tan inverse infinity, and this is minus of pi by 2 because this is given a negative sign. Or geometrically we can see a is negative, right, with I. So it's coming here only. This is like if you are putting a is equal to minus 1, minus 2, minus 3, in like the value is like anything, right? So this is minus of 2i. So angle will be minus of pi by 2, right? So we have to be careful while solving the question, right? In which quadrant this will lie is very important, right? in which quadrant this will lie is very important. So alpha lies between pi by 2 to 3 pi by 2, then we have to find this, right? We know this is already we have solved this. So we can say this is coming as minus 2 cos alpha, right? Cos of pi plus alpha plus I times sine pi plus alpha, right? So alpha is lying between pi by 2 to 3 pi by 2, right? So pi plus alpha will lie between 3 pi by 2, pi plus alpha, right, is lie between 3 pi by 2 to 5 pi by 2. And this is in the which quadrant? Obviously, we know that this will be in the, right, the rotation will be there. So minus pi by 2 to pi by 2, right? So minus pi by 2 to pi by 2, this is going for this number. So A will be our answer, right? Directly we are getting this, right? Okay. So the different variety of question would be there, like the real number theta for which the expression this is purely imaginary. So obviously we have to find the real part of this. How to find the real part? So multiplying with the conjugate 2i sine theta. The conjugate is 1 plus 2i sine theta upon 1 plus 2i sine theta into 1 minus 2i sine theta, right? So the real part will be 3 minus 4 sine square theta. So this we have to make this is equal to 0. So sine square theta is equal to 3 by 4, and directly we are getting the answer pi plus minus of pi by 3. Plus minus pi by 3 is something like this, right? The answer we are getting. So these are the few simple question, right? But if I'm going for the question of the modulus, right? Mod of Z1 plus Z2 is equal to mod Z1 plus mod Z2, right? Then argument of both. We have already seen that if there is an equality sign means origin Z1 and Z2, right? So I'm saying Z1 is there, Z2 is right in this line only. So minus Z2 will be here only, right? This is origin. So length of this will be Z1 plus Z2, and this is mod Z1 and this is mod Z2, right? Means where this argument of Z1 means angle of Z1. Let this is theta. Argument of Z2 is again theta. Both are same. So angle between both will be 0. Right? See the graph carefully. Right? One of the simplest way to find this. Right? And if I'm changing the question in the form of Z1 minus Z2 is in the mod is equal to this. Right? So 100% now you know that. Right? If this is Z1, right, we need Z2 with minus sign, so Z2 will be there. So this is Z1 minus Z2, right? Origin, this is mod Z1, this is mod Z2, right? So this length is Z1 minus Z2 is in the mod, right? Mod Z1 plus mod Z2. So both are opposite to each other. So angle between this will be either, right, we are going for pi or minus pi with this form, right? So going for the next one, right? This is purely imaginary. So what is given? In the given formation of the question, this is purely imaginary, right? So 5 Z2 by 7 Z1 is equal to I. And we have to 2 and 3. We have to multiply with 2 and 3, right? So what we required? We required this for Z2 by Z1 is equal to 7I by 5, right? Right. And what is our requirement Z2 by Z1. So if I'll divide this by Z1, right? So what we are getting, 2 plus 3 Z2 by Z1, this is 7i by 5 upon 2 minus 3, 7i by 5, right? Whole is in the mod, right? So while solving this, right, Z1 by Z2, this is 10 plus 21i, right? That's a simple calculation part only, right? And this is 10 minus 21i, right? And modulus of this. And both way you are getting, right, unity on the part, right? Again, the same question, right? Right? If Z1 by Z2 is equal to 3i by 2, again, with the same concept, we have to get the same logic and same answer would be there. So careful, remember this, right? Z1 plus Z2 mod square is equal to mod Z1 square plus mod Z2 square. Then we have to find value of Z1 by Z2, right? See, in this formation, Z1 square plus Z2 square is given as, so what we can write, this is Z1 plus Z2 into Z1 bar plus Z2 bar is equal to mod Z1 square plus mod Z2 square. Open this up. Mod Z1 square, Z1 into Z1 bar is mod Z1 square, Z2 into Z2 bar is mod Z2 square plus Z1 Z2 bar plus Z2 Z1 bar is equal to mod Z1 square mod Z2 square, all cancelling out, dividing this by Z1 Z2 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 bar, Z1 by Z2 plus Z1 by Z2, right, is in the bar is equal to 0. Now see this, if complex number Z plus Z bar is equal to 0, means real part of this, if complex number Z is a plus ib, a is equal to 0, real part is 0, means complex number Z1 by Z2 is purely imaginary. So easily we can apply the concept, right? More will go in next class, and we'll also do the previous year question in next class for complex number, right? Apply the concepts.